Welcome to my YouTube channel. Okay, so this is gonna be my first video based on calculus. Okay, we're gonna be using JavaScript to solve calculus. Okay, and then the topic we're gonna be working on today is integration. Okay, so the responsibilities is to use JavaScript, is to maintain a web-based integration calculus application using JavaScript. Okay, and then we're gonna ask for the user input right here, and then the output, which is gonna be the answers. Once you enter the inputs, you're gonna receive the output, which is gonna be the answer. And then we're gonna be using an integration algorithm such as Simpson rules to solve the integration. Okay, and then we are going to need to install this dependencies, which is gonna be maths.js and readline. Okay, so let's start with doing that right now. Okay, let me open my terminal up. Okay, so let's cd. Let me see, Alex. So cd into desktop, and then cd into MS TV. Let's clear this. As you can see, there's nothing in there, so we're gonna make a file called calculus minus integration. Okay. Okay, I misspelled that. Calculus integration. Good. Clear. And then we should be able to see. Okay, now let's see the into calculus underscore integration. Good. Now let's install. Let's open up the code. Okay, so we have the terminal up working with us right now. So let's install. If you guys don't have the terminal, there's a terminal right on called Visual Studio that you could use. There's a terminal right here, but I'm gonna stick with these. Okay, so let's create let's install all this. Let's install NodeJS into this file right here. Okay, and then npm I, which is maths.js, and readline. Okay, that's all we need. Okay, we don't need express or this dependencies. We do not need it because we are asked to integrate the maths.js library and then utilize the readline module to enter user input and displays prompt in the command line. Okay, so let's install this right here. Okay, since that is being installed, now let's touch and make an app.js. Okay, good. You know what, let's install nodemon and bmi nodemon. Okay, and then on packages JSON, you want to change this to start, and then just put nodemon app.js. Okay, pretty much simple. So on this part, this is where we're gonna be working everything that has to do with calculus. Okay, so we're gonna import the readline. Let me write that. This is just a comment. Okay, import the maths.js and readline. Okay, modules. So to import all this stuff, we're gonna do a const readline maths.js, which equals to required maths.js, and then const readline equals to required readline. Okay. Okay, so after this, we're gonna create an interface for reading inputs from the command line. Okay, and the command line is going to be on your terminal right here. Okay, we're going to show you exactly what we mean by that right now, just in a minute. So we're going to create a constant. You can name these whatever you want to name it. It doesn't have to be a R1. It could be You can name it user inputs if you guys like that. User inputs, which equals to readline. That's great. Interface. Okay, and then right here you want to put the inputs, which is gonna be process. That's stnn. Okay, and then the output, which is gonna be versus the str out. Okay, so this is, I mean, like I said, you can always change this. This doesn't really reflect anything that has to do with this. Okay, so for instance, let's console log user input. Okay, to run this, we're gonna do npm run starts. Okay, let's see what it's showing us right now. Okay, we got all these beautiful styles over here that we could use for input, and we should have one for output too. If okay, okay, we have inputs, and then output should be up there. So yeah, right here. Okay. Yeah, pretty much. Yeah, the interface. Okay, we got all this. Okay, objective stuff. Okay, so right here, what we want to do is, after asking the user to input a value, right, you want to ask the user to enter the function. Okay, function expression for f of x. Okay, which is going to be user input. Okay, remember we asking the user to enter a value right here in the output. Okay, I mean the output. Okay, so right here we're gonna do user input dot question, which is gonna be enter the function of f of x. Okay, comma the function expression. Here we're gonna compile the user provided expression using mass.js. Okay, remember from the dependencies that we installed already. Okay, so to do that, we're gonna do constant f equals to maths.js, maths.compile expression. Okay, let me make sure I tap this right. Okay, expression. Okay, has to be the same thing sometimes. Okay, expression, good. Okay, so after this, we're gonna ask the user to enter the lower limits of a. Okay, since we have, so usually when we do an integration, right, we have a lower limit and an upper limit. Okay, which is a to b, and then we have the function of dx. Okay, so for the user to enter value of the lower limits, we're gonna ask the user, which is gonna be user input dot question. Okay, enter the lower limit. Okay, of a. You don't want to put that in caps. Okay, that's a. Okay, and then comma function, which is a. Okay, so this is pretty much what we need. Okay, and then we could ask, do we? Okay, so when we ask the user to input a value, okay, and then inside. Okay, so after the user enter value of a, let's prompt the user again to ask. Let's ask the user to enter the upper limit of b. okay, which is gonna be user input, enter user input dot question, enter the upper limit of a, which is gonna be b. Since this is the function, we're just gonna do, and then right here we close the real line interface. Okay, so we're shutting down the question right here, which is gonna be user input dot close. Okay, all right, this pretty much explains this. This is the function that we need to get the upper limit and the lower limit and the upper limit. Okay, and then right here all we're doing is basically getting the function that the user provided and compiling into a mathematical way for us to for JavaScript to solve the problem. Okay, so after this we wanna so let me see what else we could do. Okay, let's define the function. Let me go back to the responsibilities. Okay, so we need to what does it says over here? So after we integrate these, implement functionality to prompt the user to express. Okay, we did this function expression lower limiting the number of okay, utilize the real line. We did that already. Ensure the application is robust, efficient, and is capable of handling various edge cases, provided accurate results. Okay. This should be okay. Implement numerical integration algorithms such as Simpson rules to calculate approximately integral. Okay. So we need to implement a Simpson rules into our coding right here, which is gonna be defined a function for Simpson rules. Okay, I'm just gonna put that Simpson rule integration. Okay, and we all know what Simpson rules integration is. Okay, so function. Okay, for you guys that don't know what Simpson integration is, let me show you guys. Okay, let me show you guys. Okay, just give me a minute real quick.
Listen to me, you keep watching.
So Simpson rules calculator. So for integration, so basically this is the Simpson rules over here. Okay, so we're gonna implement this in our coding, which is we're gonna be using where delta x equals to b minus a divided by n. Okay, all right, so we're gonna code this out. Okay, so Simpson rules, so the function of integration integrate Simpsons. Let me make sure I'm typing this right, because this is actually a function right here. Integrate Simpsons. Okay, so we have f, which is the function a comma b n. Okay, so this is basically calculate the weight of each sub interval. Okay, so constant h equals to b minus a divided by n. Okay, and then let's initialize the sum with the function values at the endpoint. Okay, so we could say constants or let sum equals to f dot evaluate x a plus f dot evaluate x b. Let's make sure you guys are very consistent when you're solving, especially when you typing out this code, okay? Because you remember a is gonna be the lower limit, and then b is gonna be the upper limit, okay? So basically we're initializing the sum of the function value at the endpoint, okay, which is let sum equals to f dot evaluate the x of a plus the f that evaluates xb. Okay, so from these you want to apply the sum rooms, okay? Apply Simpson's rules. It's kind of hard to to say that, but for the remaining sub interval, okay, for let I equals to 1, comma, I is greater than n, comma, not a comma, but, and then I increasing, okay? We want to do a function which is constant x equals to a plus I times n times h, okay? And then the sum plus equals to I, the remainder of 2 equals to 0. Two times f dot evaluate x, 4 times f dot evaluate okay. So then return the approximate integral value, which is going to be returned, basically return h divided by 3 times the sum. So right here we want to specify the number of sub-interval for Simpson's rules. It's gonna be constant and equals to 100. Okay. Specify the number of sub-interval for Simpson rules. Okay. Yeah, right. You want to calculate this approximate integral using Simpson rules. gonna be constant, which is results. You go to integrate Simpson rules. Okay, remember the function above that we created, we need to implement into the result. Okay, f, and then parse float a, parse float b, comma n. Okay, so basically what this is doing is getting the function, okay, of x, okay, and then parse float a, which is a and b, the lower limit and then the upper limit and the n itself. Okay, so then after this we just need to catalog it, the output the results to the console log. Okay, console log, let's just console log this real quick. Approximate integral, which is results. Remember guys, you need to put results. Okay, and then we should be good to go. Yes, so this is basically what we need. Okay, so let's run this right here and see if we do get the same thing. Okay, as you can see, every time we restart the code or we save it, it's asking us for the function. Okay, for instance, let's do 3. The function is just 3, which is very wrong because we can't just have a function of 3. I mean, what does it say? Math is not defined. Reference number thrown in event 71. Math is not defined. It's Master.js is never used. Oh, okay, my fault. Okay, so this is the mistake. Okay, so I was just okay. So right, we're compiling the user provided expression using Master.js. So instead of me writing just maths over here, so we could use this as the same. I was using Master.js. I mean, I could just leave it like that too, Master.js. But right here, I need to put Maths.js. Okay, so once we run this, everything should be good now. So if I put a 3, so the function is 3. Okay, and then the lower limit is 0, and the upper limit is 2. Okay. Now we are having another function f that's evaluate is not a function. Okay. Okay, what line is this? 71. Math. That's type error is f that's evaluate is not a function. Okay. Math that evaluate. Okay, we're doing the function equals to. See, that's not a, okay. This evaluate. Okay, let me copy this. Just didn't type that right. Okay. Evaluate. Okay, make sure you guys know how to type. Okay, because this is one simple mistake that we usually make in coding. So let's run that one more time. Okay, so 3 0 and 2. Okay, still showing f dot to evaluate is not a function at Simpson integration. Okay. What could be the error this time? Red line. Let me make sure. Okay, it's red line. Okay. Okay, you know what? Let me see if this is gonna fix it. Okay. Compile expression, which is expression. Okay. And then okay, it's showing. Okay, okay, x constant. Okay, constant equals to x equals to a plus I times h. Let I equals to 1. Return times the sum. Okay, that's equals to f dot evaluate. I'm still not typing this right. Okay. Evaluate. Jesus. Okay. Evaluate. Okay. Cross count. This is going to work this time. Let's see. Okay. 3 is the function, and then we got 0, and then we got 2. Great. It's working. So this is simply, just an integration that we could use. I mean, we could type in any function that we should get approximately integral. Indefinite integral, it's another way to approach this stuff right here. This is okay, there's 2 different ways. Okay, let me show you guys. Okay, let me go to my Google. Okay, so we have 2 integrations. Okay, we have indefinite integral, right, and integral itself. Okay, so we have 2 integrals. Okay, so let me see an image. Okay, this is indefinite integral. Okay, we need, yes, this is definite. Okay, yeah, I should put definite. Okay, so we have definite integration, and then indefinite integration, which doesn't have the lower limit and then the upper limit, no boundaries. Okay, this definite integral has a boundaries from a. Sorry, I didn't mean to. Okay, this one has the boundaries from a to b. Okay, well, I'm using a website from statistics how to, just to show you guys the 2 different ways to solve integrals. Okay, so the definite integral is from a to b, which has a boundaries, which is bounded from a to b, right? Since a is the lower limit, right, and then the upper limit is, the upper limit is b. So initially in math, we use a to b, right, which is a value that we was given. Okay, and then as you can see, we was given a value as we were told to use. Okay, the function expression, and then the lower and upper limit. Okay, the lower limit and the upper limit is this. The lower limit is 0, and for this case right here, the lower limit is 0, and then the upper limit is 9. And this is the function, which is x squared. Okay, For instance, okay, I'm gonna solve this. Let me see. One. Okay, let's solve this right here. Okay, f of x is 3x squared. Where's the boundaries? Okay, let me look at the boundaries. Okay, that's indefinite. That's indefinite. Okay, give me a definite integral with answer. Let me see. Let me just take a look. Okay. Good. Okay. Let's look at this right here. Okay, this is from onlinemathslearning.com. Okay, they were given. Let me see what they were given. Okay, so they were given a 0 to 1. Okay, and then the function is s squared. Okay, so let's restart this. Okay, and then go to the let me make this small. Okay, so we're just given a function which is x squared, right? X squared, right? And then the lower limit is 0, the upper limit is 1, so we should get a 0.333. Is this right? Should be right, pretty much. 1 divided by 3, 0. Yes, it is right. So, you know, we could just use this stuff right here to solve a whole indefinite integral. Okay, definite integral. Okay, for indefinite integral, I'm gonna make a separate video for that for you guys. You know, if you guys want to work on your calculus during school and you don't want to do a lot of workings, but you guys gotta understand. Okay, you guys gotta understand how to solve it in order for you to start using the coding, because you know when it comes to tests you can't code it. But this is just a simple way for you not to do this extra works. You know, you can just put in a function and solve A to B. Okay, thank you guys.